store. Yes, Andre, please, the microPET floor is yours.
Thank you very much, and sorry for the audio issues. And actually, thank you very much to Ryan, because he's been talking about the process of building a CPLD-based machine that I've been going through all the same, as you can see. So I'm talking about the modern PET replica, what it drove me to, and overview features, and I'm quickly flipping through the presentation, I guess, and then get to the demo and Q&A. So I learned programming at school on this such a 3032 Commodore PET from the end of 70s. And then I got a private C64, and that was not able to run the games. So actually, in 1989, I built my first PET replica using those perf boards. And this actually still exists. If you look on my screen, you saw somewhere here, there. It's still sitting on my desk. I probably don't see it on camera. So over the years, this machine got many more features: SCSI, SPI bus, 8 MHz CPU, Ethernet, USB, and SD cards like this card here, which has an SPI interface, an Ethernet, SD card, and USB. So, and that's what made me think about, because that was so much more integrated, that I had long on my list to put a Commodore PET on a single Euro card. PCB. So the release 1 of the microPET started with that. It's a rather classical design, and still has RAM and ROM on it. But it was a test bed. It went from composite video to VGA output, and it went from an actual ROM chip to an SPI boot chip. So I'll talk about that maybe a little bit. And here you can see the CPLD. It's actually also a Xilinx, and I know the proprietary software to use the Xilinx is really terrible, but well, that's what we have to use right now. And it's actually a 288, and it's packed. So this is microPET release 2, and it's got 12.5 megahertz CPU. That odd number comes from VGA output, because as Ryan already explained, 50 megahertz. I think 25 megahertz pixel frequency. I use a 50 megahertz oscillator. It has 1 megabyte RAM, VGA output, all the nice goody things, and even card edge connectors for the classical disk drive, for example. So system architecture is really very simple. Basically, this is a 6502 computer. Then there's the CPLD, which does all the memory mapping, and the video output and the SPI interface. And there's an additional video RAM chip. So you get 1 megabyte video in total. As I said, it's going up to 12.5 megahertz. It's selectable between 1, 2, 4, and full speed. It uses clock stretching, for those that know what I mean. And also the VIA timers, the clock stretching is done for the I/O chips as well. So if you're running a 1 megahertz kind of simulated PET, it still counts at 1 megahertz even in the in the VIA clocks. The memory map is you have 512K of fast RAM at the lower end, starting at address 0. The CPLD, which I use, copies the boot program from SPI into RAM at boot time, which is just 256 bytes, and boots the CPU, and this then actually loads the rest of the code from the SPI flash memory. The video memory is as it is on the PET on 8000 hex. You can map it to different positions. I'll show that some later in the demo. Also, the lower 32K can also be remapped to other places in the fast RAM. So that's what you can actually do to kind of run up to 4 PETs in parallel. It also emulates the 8296 extension. That was the latest and greatest of the PETs. The last machine that got 128K of RAM and was able to map the ROM area to some additional RAM. Also, because the whole memory is RAM, there's no ROM, but you can, on the CPLD, you can write protect, of course, the ROM area, so no one should be able to overwrite it. Video modes, I'll go more into that later, and that perfectly fits in after Ryan's talk. The classical 40 columns by 25 rows, and then we have, it goes up to 80 columns to 50 rows, the same as in high-res graphics, linear addressing, not like in the C64, where you have that kind of blockwise addressing. Yeah, you can have double scan. I show that in the demo, and it uses a character memory, like the typical character ROM. It's also in RAM. Everything is in RAM because there's no ROM, except for the SPI-based one. And it has a very, very basic emulation of the CRTC, the video chip of the Commodore PET. So that basically those pokes that switch over the size of the characters work. Oops. As a ROM, I built into all sets that you can think of, kind of as basic one, with a basic one character set even. And optionally, you can run a version that has fixed IEEE 488. You know, the very first PET basic one didn't work with the disk drives. I when I built the XPET emulator in Vice, I actually made a fix to the ROMs that allowed using the IEEE 488 interface, and that's here included as well optionally. You can have the basic 2 with the famous Microsoft Easter egg, and you have the basic 4 for those 3 machines, and those use Steve Gray's, optionally use Steve Gray's editor ROM project ROMs with an additional wedge and keyboard shortcuts. And you can actually also even use a C64 keyboard, because I submitted a patch to Steve Gray's ROM code to support C64 keyboards. So demo time. So let me switch over to my workbench to show you the machine. So here I put it into a nice crystal case C642 case. This my kind of demo machine. So this all stuff here is 3D printed. The keycaps are 3D printed. You can find all the designs on the web page. Also, the keyboard support plate here is printed. This is a keyboard from Steve Gray. I have another option to support for the PET skis, Tekelec PET skis, PET skis keyboard, and there is that's actually the microPET in here somewhere. So very, very simple. You have the I/O chips here on the side, the CPU, and then the CPLD. So let's show you some demo. Oops. Okay. And as you can see here, I can very easily, with a click of four keys, I can switch to the boot menu, which is changed in the Steve Gray's editor ROM as well. So let me look at my paper, what I'm going to show. So, for example, first of all, what you can see here is you have the different options that you can select from the menu, as I showed in the presentation. And if you use those are providing you the modified ROMs. So if you just click 4, you end up with the wedge ROM and all the extensions. If you use the left shift key and the 4, you end up with the unmodified ROMs. And also just clicking on using the keyboard like that allows you to detect if there's a C64 or a Commodore PET keyboard attached, and so it's done automatically. But this is not the. There's a reset switch somewhere deep down. I should probably put it somewhere else. So let's start with some video demo. So let me define an address, and then you can simply switch on high-res mode, or you can switch it off by a simple poke again. What I mentioned before is the interlace mode. If you look closely, maybe I'm not sure if you can actually see it. Only every second raster line is displayed. So this gives a nice cozy feeling of the real CRT monitors, where you have these horizontal lines between the actual displays. But if you don't like that, you can actually switch that off easily. And then you see every line is drawn on the screen without lines in between, but it looks very emulator-like, kind of, if you know what I mean. This also works in high-res mode, and then you can also switch to not using the additional lines in for displaying every line twice, but just as they are. And then if you go to this one, you can actually have the 80 column by 50 rows video output. Okay, so that's for that. And now let's see what I can show you on the here. You can run a benchmark where I'm using 2 loops. First, to calibrate the speed of the system or the measurement against the video output, because the video output, the vertical sync is still 60 Hertz. And the second loop to actually determine how fast the CPU is. And just you can see those 4 speed modes. You can see this is the fast RAM. There's no change if I change the video modes. And if I run the same tests in video RAM, you can actually see that depending on the video mode, you have some wait states. So the CPU needs to wait because the video is taking too much time. So then I have another demo for you, which I can. So I'm not going into many more details. So this is going to be the last demo. So this is actually a demo for the virtual PET features, where you can switch around the memory of the PET by a simple poke. And if you use the additional keys on the keyboard that are available on the PETSCI keyboard and on Steve Gray's keyboard, you can have. There is the second one booting. So yeah, and then I do it again. There is the third one coming up, and then you can run in the print. Okay. So you can run something, and then you have the fourth one coming up. And then you can go back to the first one, and you can go back to the second one, and you can back to this one is because those keys stop the output display. If I just enable that with the off reverse key, continues again. So yeah, in the yeah, due to the time, I'll probably not show anything else. I would like to go into Q&A mode. Thank you very much.
Yes, thanks.
Ah, wait, I can go on here and then
That
here
was
you
my
can
next
see all
question.
the. Yeah, I have a video series on YouTube, and it's all open source. It's GPL. You can use all new parts in 2021. I've even replaced the IEEE 488 drivers, and still worked with the classical hardware. I tested it with a drive or two, and so yeah. Thanks, and time for Q&A.
So you don't plan any partnership with I don't know, these companies who are building them or at least selling the parts in a kind of kit?
It's all GPS. Everyone can just take it and build it, right? Yeah. Even the 3D prints are the designs are open source. Yeah, even if you look at the it took quite a long time to actually design and print those keycaps and bring them into a good shape. Everything. So.
But all the links are from this from your GitHub page. We can find everything from there. So if a kind of cookbook or something.
Yeah, everything is on the GitHub page. That's right.
Perfect.
So there's the board layout. There is the CPLD code. I program it not in Verilog but in VHDL. There is the 3D print stuff from the for the key support. That's actually linked to I think linked to Tinkercad. There is the demo parts. Everything is there.
Perfect. I think due to the time, we know that Chris has an appointment soon. I will maybe we can stop now. And if there are questions, please type them in the chat so that Andre can remain around and answer there. I will stop the recording now.